So today we're going to be starting lesson 11-4, where we're going to learn how to find the volume of a general prism. So by just going to be going over a few definitions, showing you a few pictures for the beginning of this lesson, and then we'll get into the math part. So volume of prisms. A prism is defined as a polyhedron where the bases are congruent and parallel. Note, we're going to be naming these shapes by their base. So for instance, we could have a rectangular prism, a spherical prism, a conical prism. And each way we approach each figure is going to be completely different. Okay? So a right prism. The edges of the sides are perpendicular to the bases. We know that perpendicular means creates right angles, or two lines that intersect to form right angles, so we're going to be having some 90-degree angles. And in a right prism, the edges of the sides are perpendicular to bases, as we mentioned, so we can have a triangular prism, a quadrangular prism, a hexagonal prism, and we could even have a pentagonal prism. No, you could even have more like an octagonal prism, but the thing is, we typically don't even bother drawing them because they're actually very hard to draw by hand. Okay? Then we have the oblique prism, which is simply a prism with bases that are not aligned directly above the one other. It is tilted or slanted, and it's one whose sides do not form 90-degree angles with the bases. So for instance, you can have the oblique parallelogram prism, which is basically just like a parallelogram tipped or slanted. If you ever take multivariable calculus in college, you'll learn that these are called parallelepipeds. And parallelepipeds actually play a very, very, very unique role in three-dimensional space. We then go on to the oblique rectangular prism, where we just have a curved rectangle. And again, it simply just looks like a parallelogram. And then last but not least, we can even have the oblique triangular prism. And whenever we have the oblique triangular prism, I'm going to just zoom in a little. Our height isn't going to be the slant. Our height would be something like this. So it's going to create a special right triangle. So you're going to want to find this by using Pythagorean theorem. Okay. All right, now let's go into how we're going to be finding the volume. The volume of this is simply going to be B times H. So it's going to look something like this. B times H. But this B is not just like, oh, the length of my base or the width of my base. It is the area of your base. So the first thing you need to do when you're doing these problems is figure out what your base is. So we're going to go through these examples right here. So for instance, if I want to find the volume of this image, my volume would be BH. This is a triangle, and this B stands for your area of your base. So if I'm doing the area of a triangle, I know my volume is going to be BH over 2 times H. And then over here, I have a rectangle. So volume equals BH. And we know that the volume of the area of a rectangle is length times width. So my volume of a rectangle is going to be length times width times height. And then last but not least, I have a square. So we're still going to be doing volume equals BH. We learned in 11-1 or 11-2 that the area of a square is side squared. So it's just going to be side squared times H. Those are your formulas. And the thing is, you actually don't have to memorize what the volume is for each of these figures, because as long as you know what the area is of its base, you're in the clear. So I'm going to zoom out in case you want to take any last-minute notes. If you ever want a blank copy of the notes, just email me and then I can send them to you. That way you can look at them. But overall, just pay attention to the video. Okay, let's go into some practice problems. So let's do our first example of volume of prisms. So in this image, I want to find the volume of a prism if the base is a square with sides measuring 7 and an altitude of 3. Whenever they give you an altitude, that's a sign that that's your height. Good. So one of the nice things with this is you really don't even need to rely on the image. So we're dealing with a square whose sides measure 7. And we know that all sides of a square are congruent, so we know our area formula for a square. Well, our volume is going to be BH, so our volume is equal to BH. We know the area of a square is side squared, so volume is equal to side squared times our height. And the sides of the square are 7, so volume equals 7 squared times our height of 3. Type that into your calculator and we get 147. So 147 units cubed. And that's it. So that's how you'd find the volume of a prism that has a square as a base. That's like level 1 question, okay? Now we go on to the next question where we want to find the volume of a prism that has parallelograms as its bases. The base of the parallelogram is 9, the height is 5.6. The height of the prism is 1.5. So the first thing I do is I annotate my question so I know I'm dealing with a parallelogram. And my area of a parallelogram is base times height or length times width. And I know my height of the prism is 1.5 feet. Here's the issue. Everything else is in inches. So we need to take account of that. We know there are 12 inches in a foot. So I'm going to just convert this to inches. So times 12. And when I times by 12, I actually get 18. So this is 18 inches. So now we know that volume is equal to area of the base times the height, or big B, little h. Volume equals big B, little h. We know the area of a parallelogram is base times height. So volume equals base times height times your height. So volume is equal to 9 times 5.6 times your height of 18. We type this into our calculator and we get 907.2 inches cubed. So that is how you approach the problems. We simply write volume equals big B times h. We then replace our big B, or our area of the base, with the area of the prism that we're finding. Now let's go on to another quick question. And this one actually is just a one-step equation. It says find the height of a pentagonal prism if the volume is 18 and the area of the base is 9. So in this case, we want to find our unknown, or our x, or our height. So in this question, we want to find our height. So we're going to zoom out a little. So we know volume is equal to big B, little h. I'll put that in green. That way we know that it goes with this. We know the volume is 18. So 18 equals the area of the base is 9. And I want to find h. Well, that's a one-step equation. I divide both sides by 9. And I get h equals 2. So my height is 2. And that's all you're doing for that question. So here's what your next task is. If you're stuck, watch this video one more time. The next thing is to write one question or write one noticing you have about this lesson. Your independent practice is going to be due on Wednesday. Today is Monday, so you have all of Monday, all of Tuesday, and even all of Wednesday. It is due at 11:59 p.m. And Ms. Kimmick and I are doing something new this week because a lot of you have mentioned that the independent practice is you are having a hard time emailing us about questions in terms of like, oh, you're not really sure how to approach it. So one thing we're going to be doing this week is we're going to be putting independent practice help videos as well. It's basically going to be going through the problems real fast and basically possibly going through the setup and how to approach it. If you have any questions, please don't hesitate to email myself or Ms. Kimmick. All right. Have a great day.